What's up, Algebra 2? So this is the last video for this week, and we are going to take it easy. For today, we just have the bell work, the objective and essential question, and that's mainly going to be going towards the inverse functions Desmos activity. And I'm going to kind of explain about half of it because it's like half a lesson, half an activity. So hopefully we'll get through all of this, the bell work and the Desmos activity in less than 30 minutes. Don't hate me if it's not less than 30 minutes, okay? Whatever you don't finish today, this Thursday, will be homework over the long weekend. So make sure you finish it. Let's get started. Awesome. So what I have so far is the homework sequences and functions review. This is just kind of a general overview of everything we've learned this week. Okay? Then we're going to start with geometric sequences and arithmetic sequences. The next slide is going to be about functions and a little bit more about sequences. So I have about 3 or 4 actual questions I want to get to just so you are thoroughly prepared for the homework quiz coming up and you're thoroughly prepared to know what sequences are and how they relate to functions. So by next week, when you actually are getting closer to the test, you know what to do. Let's get started. Let's do blue. We have this question. First of all, they want us to write a formula. This is my first step. And then they want us to write the 7th term. So first step, this is a geometric sequence because they tell us. So our geometric sequence, I'll just put a G, will be a sub n equals a sub 1 times r to the n minus 1. That is my geometric sequence formula. Okay, so what is my first term? Off to the side is 36. What is my r? My r, how do I get from 36 to 12? How do I get from 12 to 4? Many of you are probably thinking, well, you divide by 4, Mr. Carlson. But is divide by 4 an actual number? No, it's not. Remember, ratios are multiplication. So we have to multiply by a number that already has division built into it. And that number, if it's 3 here, with division, has to be 1/3. 36 divided by 3 gives me 12. 12 divided by 3 gives me 4. So if I do that, yes, but if I take 36 times 1/3 or 12 times multiplied by 1/3, I get 4, I get 12, and so forth. So that's what I want, okay? Don't freak out because you see this little fraction here. 4 times 1/3 is 4/3, right? So those are my variables, a sub 1, r. Let's get started with my general formula. It's a sub 1, and then my first term is 36. My r is going to be 1/3, and then n minus 1. So this is my general term formula. That's the first thing they're going to ask. The second thing they're going to ask, and we're going to add on to our variable list here, n equals 7, because they want us to find a sub 7. So I write a sub 7 equals, my first term is 36. I have 1/3 for my r, and then 7 minus 1. What is that? Let's go to Desmos to find out. 36 times 1/3, and then to the 7 minus 1 power. Let's go to a whole new Desmos screen. Come on. Okay, so we have 36, and then 1 divided by 3. We'll get out of there. And then I'm going to go up, and then we wanted to find the 7th term, yes? So 7, let's do parentheses, 7 minus 1. Boom. So this is rather weird decimal, but the cool thing is this, guys, we can actually change this into a fraction. Isn't that great? So most likely, Math Excel won't accept the decimal. So even if you do it on here, you'll be like, what the junk, it's a decimal. Will I give you partial credit? Like, it depends. Maybe if I'm feeling it, but most of the time, just click on this button and then you'll get the actual fraction. So our answer is 4/81. We'll come back here and we'll do 4 equals 4 all over 81. Isn't Desmos an amazing tool? Yes, kids, it is. Let's go to the next one. As we're speeding up right here, we're going through arithmetic sequences. Arithmetic sequence, what is that common formula? It is a sub n equals a sub 1 plus n minus 1 in parentheses times d. That is my explicit term for my arithmetic sequence. First things first, write the formula. That's what we want to do. And then after that, we want to find a sub 20. So what are my variables here? A sub 1 is hidden in plain sight. It is 4. Right here, 4. What is my common difference? How are they differing from term to term to term? Well, I see 4, then 10, then 10, then 16, then 16, then 22, so it should be 6. I start plugging everything into my original formula, except for n, and so I get 4, and then plus n minus 1, and then times 6. Remember to distribute. So this is 4 plus 6n minus 6. What's my final answer? When I combine those like terms, those constants, I got 6n and then minus 2. So this is my general term formula, 6n minus 2. That's what Math Excel will want at the very beginning. Number 2, they want us to find a sub 20. So I'm going to add to my variable list n equals 20. I'm going to go over here and I'm going to write a sub 20. My first term is 4 plus, I'm going to write 20. Erase this. And then 20 minus 1. Boom. So 20 minus 1, if I can write it, and then times 6, which is my common difference. This is 4 plus, this is 19, and then times 6. Okay? And then by here, if you need a calculator, by all means, just use Desmos, but 19 times 6 is 54, so you got 4 plus 54, and then you got 58. Now, some of you may be thinking, whoa, Mr. Carlson, couldn't you just plug in 20 here and just do 20 times 6 and then minus 2? 20 times 6 and then minus 2. I mean, yes, you could if you wanted. Oh, it's not 54. My bad. Let's erase this. I did it wrong on the calculator. 4 plus 19. And then this 19 is times 2. Okay, so 19, and then, times 6. And then times 6 gives me 144. So 114, and then this is 118. That's my actual answer, not this. My apologies. Now, going back, if some of you are thinking, well, why can't I just plug in 20 into that formula? You can. 6 times 20 is 120. Okay, 6 times 20 is 120. And then, of course, minus 2 gives you 118. You could do that. If you feel like that's a little bit better just to take that 20 and plug it right into your general formula, by all means, do that. Sometimes I do that. Sometimes I just go to my general formula at the very beginning and just plug it in. You will get the right answer as long as you're better at the calculator than me. Let's move on. Pause it if you need to. Remember, these questions will probably be on a quiz or test at some way or another. Okay, so keep that in mind. All right, let's review functions. You will see this on your homework quiz today. We do have a homework quiz today, so I'm going to review some of this. It wants us to find the domain, range, intercepts, and the function value. Let's get started. What's the domain? I read it left to right. Where does this start existing? It starts existing right here at -3. And since it's open, parentheses, -3, comma, where does it stop? It stops existing right here on my x-axis at 0. So I'm going to do 0, bracket. What is my range? Bottom to top. So it starts existing from my range at -1. This is the -1 right here. As I go up, it stops existing, and that's 6, 7, and 8. So stops existing right here at 8. So brackets, -1, comma, 8, parentheses, because it's an open dot. Okay, intercepts. Let's erase some of this junk here so I can kind of see what's going on. What are my intercepts? What are my x-intercepts? My x-intercepts. Right here I have 1, so that's -1. So boom, that's my x-intercept. What about my y-intercept? My y-intercept's right here, also at -1. And now I want to find f of -2. F of -2 is right here. That's what my x is. Remember, this is my x. So I go up and I try to see where does it hit my graph. It It hits at 1, 2, and 3, so that means f of negative 2 is 3. This is a point, by the way. This is negative 2, 3. Okay, but all you need to write down is that. Smiley face. Okay. Rewind that if you need some extra help with that. Let's move on. I'm going to go fast because I want to kind of make this video a little bit shorter. Here's another one that you'll probably see on your homework quiz, so I wanted to go over it. So make sure you are paying attention, write it down so you can use it. I have this quadratic and I'm given these values. Let's go to town. We'll make A red, we'll make B blue, and then let's just do for C green. Because you know why not. Okay, so f of 2, what is A? I'm going to plug in f of 2. I'm going to plug in 2 anywhere I see an x in my problem. Don't forget to square it. So that means I have 2 squared and then minus 8 times 2 and then plus 4. Let's go to town. Simplifying this, 2 squared is 4 minus 16 and then plus 4. We read it left to right. So that means 4 minus 16 is negative 12. Okay, and then plus 4, and then this right, of course, is going to be negative 8. So this is my final answer for A. Let's go to B. B, what do I have? I have f of x plus 8. I'm plugging x plus 8 everywhere I see an x, including this, where I'm going to square it. So that means I'm going to plug in x plus 8, square it, because that's what my problem says right there. Yes. And then minus 8 times x plus 8, and then plus 4. So that's what it looks like when I plug in, substitute, literally, I'm substituting x plus 8 inside of my function. Now, let's go to town on this. This is going to be foiling, so that means it's going to look something like this. I need to multiply it twice. I could distribute this right away so I can combine like terms. So this is actually going to be not positive. It's going to be negative. This is going to be negative 64 and then plus 4. So I can combine those. Now, what is this? How can I combine this? This is FOIL, remember? So first, outer, inner, last. First, outer, inner, last. So x times x gives me x squared. X times 8 gives me plus 8x. 8 times x gives me, again, plus 8x. 8 times 8 gives me plus 64. One important question. Are you ready? How many terms are in this little parentheses? X and 8, that's 2. How many terms are in these little parentheses? X and 8, that's 2. What's 2 times 2, guys? 4. So 1, 2, 3, 4. You will have 4 terms before you start simplifying. Okay. What is this? This is negative 8x, and then this becomes negative 60. So let's start combining these terms. I can combine that with the other x's, and I combine the boxes together. So this equals x squared. One of these 8x's will go poofy with that one, so that means I'm just left with 8x again, and then this becomes just plus 4. Okay? And so that is my final answer. Sweet. Let's go to C up here. So C, I'm going to actually take negative x and I'm going to plug it into my function anywhere I see an x. So it's going to look like this. Negative x squared minus 8 and then negative x and then plus 4. Awesome. So what happens if I square a negative? It becomes a positive, but because it's a variable, I'm still going to keep that squared on top of it. Negative times a negative gives me a positive, so 8x and then plus 4. So I actually get the same thing. That's kind of interesting. Smiley face. All right. That is how you go through that. Again, rewind it if you need to. I'm going to continue on and start smashing out these Bellwork questions. Let's erase. All right, so this is what we got. I'm going to go through this one a little bit more quickly just because it doesn't have anything to do with functions. I just want to review it because I think it's just helpful. So this one is going to be a 3-parter. And the first thing they ask you is divide the population for each year by the population for the preceding year. What does that mean? It wants you to find your R. Show that this state has a population increase of approximately geometric, which we will, and then select the correct choice, blah, 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 blah. So what does A say? A just means in order to find R, I'm going to take A sub 2 all over A sub 1. That's all it means. What is my a sub 2? Well, my a sub 2 is this. My second term, this is my first term, this is my third term, and of course this is my fourth term. But I really just need to know those. So I'm going to take 37.33 and then divided by 35.89. That's a 3. When I do this, I actually get a 1.04, and this is roughly geometric. If you remember our baseball example with the salaries, it was sort of like that. I think it was 1.06. So it's roughly geometric. That's good stuff. So now what we want to do is go to B. B is saying write the general term. Well, the general term is really easy. I have the first term and I have the R now, so I'm going to write a sub n equals, first term is 35.89, and then times my R is 1.04, and then n minus 1 in the exponent. So that is my general term formula. Don't get confused when it says n after n years after 2002. Don't really worry about that. What you really need to worry about is what C is saying, and this is probably the most complicated. It's saying project the state's population in millions for the year 2012. Now here's the thing. You only have 2003, 2004, 5, and 6, right? You need to find what's 2012. But in order to do that, you need to find a particular term. What's a particular term? How many years have passed? N is literally years past. So how many years have passed from your first term to 2012? So we take 2012 minus 2003, and so we get 9. Now that we got 9, okay, we start plugging into my actual formula here. So a sub 9, I'll move myself. Is that okay? So a sub 9 equals, and then we have 35.89 times 1.04, and then I'm going to take 9 minus 1. Could you plug this in Desmos? Absolutely. You can plug this in Desmos exactly how you see it, which is fantastic, but you don't need to, okay? Because I already have the answer. It is 49.12, okay? This is how much the population will have in millions, roughly, in 2012, all right? Sweet. Go ahead, take a second, get all that down, please, please, please. I'm going to race. Let's go to town. What's the next one? Let's go to the next one. Whoops, I went a little bit too far. Okay, this is the next one. Let's go and see what it's about. Something very similar, so I'm going to go through this a little bit quicker because it's similar to the functions, but you will probably see on the homework quiz. First things first, A, find the domain. Let's actually do that right now. So A, what's my domain? Left to right, we have arrows here. And so here's the important part. Since we have arrows, it's actually expanding out like completely, right? So it's going all the way over here, all the way over, so it's going everywhere. What does that mean? It means, will it always hit an x value? Yes, which means this is actually negative infinity to positive infinity. Because as I read it left to right, there's not a single spot where this graph doesn't exist. And since there's not a single spot where this graph doesn't exist, that means it exists everywhere. Negative infinity, positive infinity. Now let's go to B. Find the function's range, bottoms up, right? So I go down here, does it exist? Yes, it's pointing down, so I know it exists down here, negative infinity. Now as I kind of trail up my y-axis, I'm going to start seeing where does it stop? They give us a helpful hint here. Isn't that so nice of them? Yay. So graph approaches but never touches the x-axis. So that means it approaches, yes, but never it touches. So that means it's there, but it's not included, which means what is this y value? It's actually 0. And since it's there, but it's not included, are we going to use brackets or parentheses? I hope you're saying we're going to use parentheses. So that's what my domain and range interval notation looks like. Let's go to C. Are there any x-intercepts? Well, if it never touches the x-axis, are there any x-intercepts? No, there's not. Let's go to D. What about y-intercepts? Where does it cross the y-axis? There's actually one spot where it crosses the y-axis right here at -3. Boom. So we're going to write -3. Sweet. And then we want to find the missing value of that function. So this is 1. So if I go to 1 f of 1, I kind of scroll down. This is 1 right here, my x value. Scroll down, scroll down, scroll down. It's kind of hard to see, but it would be something like around here, which of course is -6. That's where it corresponds to. So that means this is -6. F of 1 equals -6. Another smiley face for the road. Angry unicorn. Okay. Sweet. Like I said, I'm going through these fast because I want to keep this video semi-short. All right. Now, what you will be responsible for doing is, of course, the homework quiz. I'm going to put it at 30 minutes this time, 5 questions. It is open notes. Feel free to use as many notes as possible. After that, review your answers. Send any partial credit to me. This homework quiz is notorious for getting partial credit because you could put a negative somewhere or miss the parentheses or bracket. Please send me partial credit so I can go in and give you a little bit extra points if need be. After that, you're going to begin your homework assignment, Intro to Inverse Function. So go ahead, pause the video here, and we'll get started on the Desmos activity. All right. Here's the Desmos activity. Okay, so in this activity, you will understand how inverse functions work, not just algebraically, but geometrically. And really, that's just graphically. We will look at the geometry of inverse functions by looking at the graph. We'll look at the algebra and solve it out abstractly. And then we'll also look at domain and range and how they relate. It's a great, awesome activity. I'm going to go through the vast majority of it with you. So please, if you want to follow along, go to student.desmos.com, type in this code, or go to Google Classroom and then click on that link right underneath all the PowerPoints. It's right there. It will take you straight up to this spot. Let's get started. Okay, so in this activity, again, we're going to be looking at domain, range. We're going to be looking at inverse functions. How do they relate to functions in general? How they relate to domain and range, and then we're going to look at how to use algebra and geometry with it. Not a lot of geometry, just a little bit. So first off, here, I want you guys to just answer this. What's done cannot be undone, or can it? If you cheat on your significant other, can that be undone? Probably not. Okay, but what does it mean to undo something? Give me an example. Give me an example of what it means to undo the process of doing something. Maybe tying your shoes, right? You retie your shoes, you untie your shoes. Maybe getting dressed or undressed. Maybe erasing. You have a math problem, you're erasing. So give me an example here, something original that you're thinking of. Here's an interesting spot. I actually did go to Italy, and it was an amazing, amazing time. I had to go to Italy last summer. I went to Italy with my wife. It was our honeymoon, long overdue. And we needed to get all this money for euros. And we had to transfer our American dollars to euros. And for here, this is India, right? So $100 equals roughly 6,396 rupees, okay? This obviously, I did not go. This was from another friend. I stole this Desmos activity from another friend. But then before I was going to return home, I wanted to convert my extra money back into dollars. How could I figure this out? So I have something equals 100 rupees. And so obviously this is this right here, right? But try to see if you could figure it out. Obviously, it's going to be a really easy answer, I promise you, but go for it. Now, on this next slide, you're going to be given something like this. Now, match the inverse operations. There's this thing where we're talking about inverse operations when it comes to mathematics. And we do it all the time, but we don't really do it with functions. We just do it with operations. So that's why we have inverse operations. So let's see if we can match it. Let's start out easy. Let's start out with left, I see left. What's the inverse of left? There's only one thing that would make sense here, and it is actually right. So I'm going to match those. What about addition? What's the inverse of addition? You should be thinking, yes, you're right, subtraction. Okay. What is the inverse of multiplication? It is, of course, division. So I'm going to put those here. And now we get some of these hard ones, but here I see -5, that's subtraction with addition. And then I see square and square root. Yes, you're right. Square and square root. Those are inverse operations. And of course, I have my last one right here. Now notice this one. Notice this. Watch. Look at this. 2 and 3 and 3 and 2. You're telling me those are inverse operations, Mr. Carlson? I'm telling you yes. Okay? Yes, they are inverse operations. When you flip the input and output, the domain and range, they are inverse operations. And we already know what domain and range are, right? We should. We should. So let's go to the next one. And let's see what it's asking here. What it's asking is this, guys. Look at what it's asking here. It's saying plot the inverse coordinate points for each of the green points below. So this is a point. All you have to do is click on it. Okay. So let's go over here. And this first one is 3, 0. So if on the last slide it was 2, 3 and the inverse was 3, 2, what is this? If I have 3, 0, the inverse point would be 0 and then 3. Now notice where I have a blue dot here, right? I have a blue dot. So now let's kind of cancel out these other ones. This is 6, 1. So let's go over here and just put 1, 6. Not 6, 1, but 1, 6. You'll start to see other things happening here. 6, 1 instead of or 1, 6 instead of 6, 1. You'll be going to this one, -3. So let's put -3, 4. And then we'll do our last one right here, -1, -4. So that means -4, -1. Now notice what's happening here. Let's move on to the next slide. What type of transformation happened? What type of transformation happened from here to here, from here to here, from here to here, and then this one is all the way up there? What type of transformation happened here? What do you think? You should all be thinking reflection. Okay? Remember your geometry? Remember I said it was going to be bringing back some geometry? This is a reflection here. Okay, so reflection. Share with the class. Yay. Okay, so now what we're going to be doing is going through what is an inverse function, how does it relate to functions. So feel free to write this down. I'm not going to have you guys write this one down, but this is what it is. If I have a function, f of x, its inverse is what we call f of -1 of x. We don't actually say that, but it literally is f to the -1 of x. But we don't say that. What we say is it's just the inverse of f. So we don't ever say f -1 of f or of x. We don't ever conclude that -1 because technically it's not a -1. Okay, we just say that's the inverse of f. So domain and range, they also flip. Okay, so what does that mean? It means they flip right here. Okay, so that means, look at this, 2, 9, it becomes 9, 2. 4, 5, it becomes 5, 4. 11, 6, it becomes 6, 11. So really what we're doing here, look at this. I love this picture. We have apples. It goes through the function and we get lemons. But then if you put the lemons back into an inverse function, it pops out apples. Okay? So it's this kind of inverse undoing relationship in mathematics here. So let's erase. Let's go to town on the next one. So this is kind of briefly just showing everything. I would write this down personally. The inverse of a function undoes the function rule. Instead of ordered pairs, it reverses x and y's, which we've already seen. And so in other words, the domain and range are switching places. Interesting. The graph of the inverse function of the inverse of a function is the reflection over the line y equals x. What's the line y equals x? 5 this. The line y equals x is this line that kind of cuts straight up in the middle. This is y equals x. This is also what we call the identity line. Okay? This is what we call the identity line. All right. Identity line. Let's get started. Now, the methods of finding inverse. First, if it's an ordered pair, interchange the y and x coordinates. Second, if it's a graph, reflect over the line of y equals x, which we're going to do both. And then third, we're going to find an equation and actually interchange the domain and range, the y and the x. After that, I'll pretty much kind of leave the leftover examples for you. I'll probably get to about slide 16 here, and I'll leave the rest for you. So I'm doing a lot of your work. You're welcome. Okay, so find the inverse of the function using the table feature. So what does this mean? I have coordinate points, right? And I'm just going to flip them. So I have -2, 3, so I'm going to write 3, -2. Okay, see how it's right here? I can even add this line. It doesn't have it here, y equals x. This is my identity line. This is the line that they actually flip past, right? This is the line that they flip past. We'll just put it in black here. We'll be done. Now look at this. Watch. If I actually counted these spaces here from here to here, it would be the exact amount of spaces because it's an inverse. Let's just do one more here. Let's do -1, -7. So actually, you know what? Where is it? -1. Let's do this one. Actually, no, let's do this. 3, 5. Sorry. I just want you to be able to see it. So let's do 3, 5. So I'm going to do this, 5, and then 3. Perfect. Yep, I see it right there. Sweet. Okay, so do the rest of it. That's the rest of it for you. Make sure you complete the rest of the chart. Let's move on. Now what it's going to say is find the inverse of the function using the table feature. Well, I have coordinates here, so let's go to town. 0, 1. I'm going to, or 1, 0. I'm going to do 0, 1. I have -3, 5, so I'm going to do 5, -3. 0, 4. I'm going to do 4, 0. Flipping the x and the y coordinates. And now watch this. Look, is it reflected across the y equals x line right here? Absolutely. Okay, this is my identity line. That means once it flips, it has a whole new identity, and it's fantastic. It looks kind of like a weird looking bug. Yeah. Let's go to 11. Now this is what it's going to be graphically. So solve it graphically. What will this look like? Okay, what will this look like? Type the equation in this. It's going to be a little harder, but we can kind of analytically think about it. This is multiplication, right? What's the inverse of multiplication? Division. So now, what's the instead of 2, I'm going to write y equals 1/2 and x. So now the division is introduced instead of the multiplication here. And now what it does is it actually does a perfect reflection across the identity line. Perfect. So now let's get to something a little bit harder. How do I actually algebraically find the inverse of a function? Well, I have the steps here written for you. So to replace y with x and the x with y, switch the y and the x. And then step 2, solve for y itself. So first things first, they want us to find this, the inverse of this, y equals x minus 1. So the first thing is I'm going to replace the y with the x. So watch what I do here. I'm going to take x and y, and I'm actually going to switch spaces with it. So equals minus 1. So what I did here was I actually switched those together. Now my second step is to solve for y. How do I get y by itself? Of course, I add the 1. So that means I get y equals x plus 1. This is my inverse that you'll be putting right here in this little box. Okay? That wasn't too hard, right? That wasn't too difficult. We can go to a little more complicated ones, though. So let's go to this one. Actually, no, you'll just graph that. So graph what you just got. and I'll just show you. This is x plus 1. So notice how it's literally reflective across. It's literally a straight reflection. Okay, I'm not going to show you the graphs later, but find the inverse of this. I'm going to give you actually a second or so. So go ahead and pause the video if you need to. Pause the video and see if you can find this by yourself. Okay, let's go to town. Okay, this is my actual function. My first thing is I'm going to switch the y and the x. So x equals 2y plus 8. And now I'm going to solve for y. So that means I'm going to subtract the 8 over, and then I'm going to divide by 2, divide by 2, divide by 2, divide by 2 by everything. So that means I have y equals, because that goes poofy. What's x divided by 2? That's just 1 half x. X divided by 2 is literally just 1 half x. What's negative 8 divided by 2? Negative 4. This is my inverse. Sweet. Not too difficult, right? I mean, it's just really just switching x and y and then just solving for it. Okay, so let's erase this. Now, I want you to try to find this one, okay? Try to find this one by yourself. So as I switch them, okay, I'm just going to go straight up into switching them, okay? Straight up into switching them. It should look like this. And then my second step is to actually solve for it, okay? So I have x minus 1 half, because I need to move the 1 half over. I need to get y by itself. 2 all over 3, and then y. Now what do I do here? Well, what I would do here is just simply multiply by 3. Okay? Now why would I want to multiply by 3? Because I want to get this 3 out of the denominator. I'm going to multiply everything by 3. And this whole side I'm going to multiply by 3 over 1. So the 3's go poofy. Now what am I left with? I'm left with, once I distribute, this is 3x minus 3 halves equals 2y. Okay? Now here, I'm going to multiply by 1 half. I know I'm not following my hint here. Whoop-de-doo. I'm going to multiply by 1 half. You could say, well, I could divide by 2, right? Yeah, but do you really want to divide with fractions? Multiply by 1 half. It's the exact same thing. The 2's still go poofy. So then multiply by 1 half, multiply by 1 half. So now what do I have left? I have left y equals. What happens here? I distribute. 1 half times 3 is just 3 halves x. And then 1 half times negative 3 halves is actually just negative 3 all over 4, because 2 times 2 is 4. So this is my actual inverse. A little bit more complicated. Okay, it's a little bit more complicated, but I hope you can kind of understand how I did the math here. Replay it if you don't. Let's erase. I'm going to do one more example, a little bit more tricky one, and then I'll leave you be. Okay, I'm going to skip a couple slides all the way to, I'm going to skip to this one, slide 18. Find the inverse. We said at the very beginning, what's the inverse of squared? Square roots. So that means when I look at something like this, I'm going to, first step is I'm going to square root both sides. Okay? That's usually what we do when we see a square root. That's what I would do. But since I want to find the inverse, here's what I'm actually going to do. I'm going to switch the x and the y's. So now I have x and then y squared. Now, of course, we can go and square root. Square root. The square and the square root go poofy, and I'm left with y. And then what am I left with on the other side? Square root of x. Now, technically, some of you smart kids may be looking at, well, isn't that plus or minus? Well, yes, it is. But what happens when you graph this? I'm going to graph this right here. Watch. Let's go to the next slide. Okay? Let's go to the very next slide, okay? And I'm going to graph this. So I'm going to do y equals the square root. You can actually type in SQRT. And if you don't want to do that, the square root symbol is all the way down here. So then you would just hit square root right here. I'm going to literally just type in x. Now this is what I get. Now watch this, watch. I'm going to do that, but watch what I do. I'm going to type in y equals negative square root of x. Look what I did here. Look what I did. This is something that's very, very interesting. Okay? Now watch. Actually, I'm going to make these, let's make them red. Let's make it red. So this is my original function right here, y equals x squared. And this right here is my actual inverse function in red. Now why, when we usually solve it, we just got square root of x, the positive one. This is the positive side. What happens when I include the negative side? Because this was technically, I took the square root. It's technically plus and minus x, right? That's what happens when we take the square root of something, plus or minus x. I get this, but why don't we ever write that? It's because what happens when I do the vertical line test? What happens when I do the vertical line test? It does not pass. This inverse function would not actually be a function, right? So in order to keep it a function, because remember, a function can only be a function if it passes the vertical line test. If it doesn't pass the vertical line test, it's not a function, right? And this is not passing the vertical line test, so therefore, it's not a function. How can I make it into a function? How can I make it into a function? Well, I can do one simple thing. I can just get rid of the negative. Now what we can do is look at this. If I do the vertical line test, is this a function? Yes, because it only passes through that function, that graph, one time. So this is the actual inverse function of x squared. So when you go, I'm going to just make sure you write that, make sure you get that down, and I'm going to erase. Now when you go to this last slide, these last couple slides here, specifically this, what are you going to do? What are you going to do? And this is the last one I'm going to do. You're going to do the exact same thing that you normally do. You're just going to flip the x and the y. So this is x now, and this is y. And then this becomes minus 4 squared. What do? I do it like normal. I square root. This is square root of x. Now the square and the square root go poofy because that's inverse operations. Inverse operations go poofy, and so minus 4. Plus the 4 over, I have square roots, plus 4, and then this is 3y. I divide by 3, divide by 3, divide by 3. So what is my y? My y equals 1/3 square root of x, and then plus 4 all over 3. This is my inverse. Really nasty, but still an inverse. Okay, still an inverse. Okay, I want you to finish the rest. Finish the rest as much as you possibly can. Okay, I'm going to erase this, and let's go back to our closure. Okay. So this is our closure. Remember to review your notes. Whatever you don't finish with that inverse functions Desmos activity is going to be homework for the weekend, but I would hope that you finish it today. So whatever you don't finish will be weekend homework. But other than that, you don't have any other homework. Finish up the homework quizzes. You had 3 this week, the arithmetic sequences, the geometric sequences, the actual functions one. A lot of you got zeros because you just didn't do work last week. Don't let that happen this week. If you have any other questions, any other concerns about the Desmos activity, about just the homework quizzes, please let me know. I really hope you enjoy your 3-day weekend. Okay, I will be working, but you won't. So enjoy your 3-day weekend. I am signing off. Don't forget to like and subscribe to C Squared Mathematics. I'll see you guys later.